Now this illustration deals with the grounding electrode conductor when multiple separately derived systems are involved in accordance with 250.30A6A as in Apple. Now before we get into this in more detail, let's review the notes 1 through 3 first. Note 1 to the left there, an effectively grounded structural building steel should be permitted to be used as the grounding electrode means in 250.30A4 item 2. Now basically, you know from your experience, that means the structural steel has to be accessible on each one of those floors in the illustration for that to come about. Now note 2, conditions of transformers should be permitted to be made with a listed accessible and reversible compression type connector to copper bus bars not less than not less than 1/4 inch by 2 inch, which we call exothermic welding, which a lot of us, use the old Cadwell. It shall also be permitted to be used in accordance with 250.30A6C as in car. Now, if my memory serves me correctly, if we looked at the Emerald book of IEEE, after about 250 kc mil being routed, as you see in the illustration, from floor to floor, connected into the grounding electrode system, and this is what we call a common grounding electrode conductor per code. Read all about it in 250.68 and 250.64 of the code. Then they suggest going to the bus bar. And notice that's the minimum bus bar that you could use, or maybe even a larger one. And you'd say, well, why would I want to do that? That would be like that transformer you see in the illustration. It could be a K-rated isolation type transformer with a tap from the secondary to the panel board. And we would have isolation receptacles at the locations fed from the circuit breakers and the panel board. And we wouldn't want to pick up noise or antenna type effects. Unwanted noise that sensitive electronic equipment on each floor would sense and malfunction. Now, if you can't get to the structural steel, then it's common, to run up a conductor that you see in the illustration. And then again, it's up to the designing engineer where they want to say, size it, up to 250 for sensitive electronic equipment that may be installed. But notice it's not unusual to set a K-rated isolation transformer on each floor to feed isolation receptacles, 250.146D is in dog, to cord and plug connect equipment or hardwire sensitive electronic equipment in accordance with 250.96B that we kind of reviewed. Now, keeping that in mind, the third bullet up there says step 1 is no longer necessary per NEC. Now, we're talking about the step 1 in the boxed in information. Now notice we do have separately derived systems on 7 floors. We're calling out just one of them on the 3rd floor. So that's why sometimes you need a bus bar, is to reduce as much as possible, resistance between the 7th floor and the 1st floor. You want that impedance reduced to where noise doesn't become a problem. So either use like a 250 kc mil conductor, if that's your designing engineer and what you want to do. You have to figure that out, based upon the IEEE Emerald book. Gives you a good illustration of that. And we have a grounding book, Stallcup's grounding and bonding book, that has a full chapter dedicated to grounding schemes for sensitive electronic equipment. And that information is taken out of the old Phelps 94 document as well as the Emerald book, and it just helps a designer expedite their design quicker is all. You can dig it out for yourself. That's not a problem. But notice we're looking at 240.21 C as in car 2, 250.30 A6A as in apple, and 250.30 A6B as in boy. Now that's called out there where it says, yeah, we have 7 transformers, 1 on each floor, starting with the first floor up to the seventh floor. And we just called out the 3rd floor there. But notice in times past, step 1, they would take the 4-aught conductors tapped from the secondary side of that transformer and terminate it in that main. And they'd get the circular mill rating from Table 8 to Chapter 9 for that 4-aught, which is 211,600. And they take the 7 floors and multiply times that 211,600 circular mill, and they would come up with that figure of 1,481,200 circular mill, which would put them automatically in most all cases. They'd use a bus bar. And that would, we found out, no, that's not what the code panel 5 meant for us to do. So they had to come back and correct that. So in step 2, in the section 250.30 A6A1, as well as table 250.66, we only had to use a maximum size of 3-aught to serve as a common grounding electrode conductor, but maybe you'd have to increase it for sensitive electronic equipment that's installed on each floor. And then you may have to use a bus bar to cut out such unwanted noise and signals that would interrupt the operation of your sensitive electronic equipment. Now, that's what our figure 16-46 is illustrating. The grounding electrode conductor means and how we could provide it when multiple separately derived systems are installed in accordance with NEC 250.30 A6A.